Now, we'll dive into the powerful world of data visualization and analysis using R. In this video, we'll walk you through a comprehensive R script that's designed to handle geospatial data, process results, and create insightful visualizations. Data visualization takes complex numbers and statistics and presents them in a way that is easier to understand. For instance, while metrics like compensated variation give us useful insights, maps have a distinct advantage. They visually show how economic variables are spread across the different parts of the city and make simpler for policymakers to see and understand spatial patterns and trends. This can help you make more informed decisions by giving you a clearer picture of how different regions of the city are performing in economic terms. Let's walk through the steps to make maps in R. In the first section of this code, you will set up the working environment by choosing a path where all your files will be stored. We will also clean the workspace to remove all objects that are stored in the environments and we are not going to use in this moment. Additionally, we will source an external code that we have already prepared and set some basic parameters for doing the maps. You will find this code among the files of this course, and you will be able to modify it to set your own parameters and preferences. Finally, we will define some parameters for performing winsorization of some variables that we will be mapping. This will help us to avoid outliers in our maps. Now, we can import all the files with the characteristics or the results from the inversion and solving of the model. One important step is making sure that the results of the inversion and the solving of the model have an ID variable. This ID variable should be the same that we had in the original dataset of characteristics. You can do that by using this line of code. This is important because the ID variable is what will allow us to merge the results of the model with the shapefiles of the city. The next step will involve reading the shapefile of the city of Amman. To do that, we just need to make sure that we are using the right packages in R. In this case, we will make sure that the package SF is available in our environment. To do that, we will type library SF. Then, we will be able to read the shapefile. We will also need to assign an ID to the locations that are shown in the shapefile. In this case, as all the observations have the same order, I can assign this ID by setting a sequential number for every row. Then, I am ready to join the shapefile with the results of the inversion of the model by using the ID that I have just created. Now, we are ready to plot a map of any variable that has been obtained in the data frame of the inversion model, such as productivity, amenities, or salaries. In this case, we will do a map showing the productivity in the city. Before we do that, we need to make sure that the required packages are available in our environment. Then, we will apply a statistical technique to reduce the outliers in our data. We are now ready to plot the results in the map and finally save it. First, we will need to classify the values of the variables into a set of categories that will define the colors of the map. To do that, we will use the function class intervals and create a vector of breaks that then will be used in the map. Now, we are ready to start plotting. We will use the function ggplot. I am specifying in the ggplot function that the main map will be the division of the city of Amman. Every location should be colored using the variable of productivity, and this variable will be classified into a set of breaks that we have just created. I can also specify some aesthetic elements like the title of the plot and the position, width, and height of the color bar. You can see in this example that the most productive areas are those around the city center. Another option would be plotting maps for the different counterfactuals that you simulate in the model. You can do that by using percentage changes or absolute values. In this case, we're going to plot a map of the percentage changes in the number of workers. First, we need to calculate the percentage change in the number of workers using the results from the counterfactual and the results from the baseline. We will also apply our winsorization technique to avoid any outliers. And as we did before, we will need to use the shapefile of the city of Amman. Now, to do the map, you need to create the breaks of the variable that you want to plot. Then, using ggplot, you can make a map of the percentage change in workers. You can see that some locations are seeing reductions in the number of workers, while some other locations are seeing increases in the number of workers. You can export the maps into various image formats such as JPG or PNG.